Gravity based system is very good, it is cheaper, there is no extra energy required, just you have one mechanical design and fluid will be flowing and you are separating oil and water. But that is not so much efficient, so there are some other technology, one called centrifuge. Centrifuge is very heavily used in medical industry like drug discovery or maybe blood sample separation, like blood cells and serum is separating. In that case they use centrifuge. I mean milk and butter separation, they also use centrifuge. So centrifugal liquid separator, it consists of rotating cylindrical container with stationary one. Okay, so it will be, let's say I have taken certain sample oil water. Okay, oil water sample. Now if I rotate it high speed, okay, give high speed rotation, spin, then what will happen, the oil and water will get separated. Okay, so this one your low density oil, this is high density water. Because water is high density, if you rotate at very high speed, what will happen, water particle, high density particle will try to take larger diameter, or it will try to go away from your spin of rotation. So high density particle will be collected at the bottom of your tube or separator system, while oil will be collected at the top of this section. So in this way you separate, and the separation efficiency is very high, you can reach to 5 ppm also. Okay, consists of rotating cylindrical container. Cylindrical container you can see here. Pump a mixture of oil and water into cone shaped separator, so it will be cone shaped, creating spinning vortex. So you are creating at very high speed. So water denser accumulates at the periphery, collected from the side. Oil less denser accumulate at the center, collected from there. Okay, now denser particle settles at the bottom. Denser particles settles at bottom. So we can say sits away from axis, spinning axis. Okay, so particles sedimentation into pellet, particles sedimentation into a pellet at the base of the tube. Okay, centrifugal force is used. Okay, centrifugal force is given and replacing the gravitational force. Okay, which is responsible for sedimentation of two-phase particles. So you can have three-phase or multi-phase also. For example, solid is there, solid will be further away from water, solid, then water and oil. So different phases you can separate if you have centrifuge, and because you are creating very high amount of force for separation, so it will be giving higher efficiency than your normal gravity based separation. Gravity separation is having limitation because system is very slow, but in this case things can be very fast, but you need mechanical or electrical energy or mechanical energy to give in the system. So this is actually similar to the centrifuge, is similar to hydrocyclone. Okay, so there are lots of research paper, they are suggesting to use hydrocyclone for oil water separation, but whether I don't know anyone has used for your bilge water separation, because this is also a very simple case and you need maybe mechanical energy, but it can separate different density fluid, this is especially oil and water. So design is like this, it will have one cylindrical section, then cone section. Okay, now you will have an inlet pipe, inlet oily water, and when at high velocity, when inlet fluid at high velocity will be entering, it will be creating one vortex like this, and it will be coming down. So inlet will be creating one tangential. So if I take top view from there, so inlet is like this. Okay. So it will create tangential entry. So tangential entry of oily water. Okay, so oily water will be tangentially entering and it will be rotating, and because of gravity slowly fluid will be falling down, or it will be going down. But when it is going down, the high density particle will try to touch this surface area, okay, inner wall. So high density particle will create layer here, rotating but near the wall. Okay, high density rotate and create a layer near wall of the hydrocyclone. Comes down, while the low density particles creates a central layer, creates or rotates, low density particle rotates near the center of the hydrocyclone. Okay, so what happens, high density particle will be rotating at a very high speed and it will be touching near the wall. Low density particle, because density low, so they will not get space at larger radius, so the center area they will be rotating. Okay, so central area you put one other pipe here. Okay, then you suck the low density will suck and take out. Okay, so high density fluid will be rotating and it will be moving down, while the low density particle will be rotating at the near the center. So there you put one pipe and suck from the top. So two fluid already separated inside the cylinder. One particle already will be falling down because of its own density and gravity, and while the low density particle will be rotating the center, from center you just suck it, so you will be separating this one. So any two fluid with different densities, like say sand and liquid, or oil and water, or maybe dust particle in air, so you can create such cyclone and you can separate actually. Okay, so this is called hydrocyclone. So hydro means water, cyclone is like spin you are creating, so using this one. So this is not, there is no mechanical rotation, actual mechanical rotation moving element, so this life is longer. So this is very much commonly used for many industries to separate particles. Only you need the inlet high pressure fluid, high pressure or high velocity fluid. So if you have available high pressure, high velocity fluid, then hydrocyclone can be your very good choice. So petroliminator or OWC, or oil water separator. So here I have taken from Ensolve company. So they have this product, Ensolve Biosystem. Okay, petroliminator. So this is a biochemical water and oil separator, and they use actually some chemical to separate. So this is non-precise 3-stage vessel, 5 to 20,000 gallon of oil water per week they can process. So they have 2-stage: heavy phase separation removes pure oil. Second stage, oil degradation, non-pathogenic microbes will be working and they will be separating. So how this microbe work, I'll explain. So oil degrading bacteria occurs naturally in the environment and degrades oil slowly. In bilge or oily water holding tank, high concentration of bacteria inducted, but they quickly die off due to lack of nutrient oxygen. Aerobic bacteria cells like Pseudomonas possess natural biosurfactant coating around the cell wall. Inside the cytoplasmic membrane, multi-enzyme complex metabolize organic pollutants. These bacteria break down the oil, very long chain hydrocarbon, to small chain hydrocarbon, with certain specific being more effective at metabolizing specific molecules. Hydrocarbon molecules diffuse through the cell wall and are broken down by enzyme in the first stage of intermolecular metabolism. The remaining component diffuse through the cytoplasmic membrane, degrade further by multi-enzymic complex. In the presence of oxygen and nutrient, the bacteria break complex hydrocarbons into carbon dioxide and water. So Pseudomonas it is found in soil, water, and plant animal. This species, Pseudomonas putida, is widely used in oil spill application. Okay, now you got oil and you have gravity settling chamber, because that will be removing larger amount of oil particle, and very small particle you are not removing, or if you have any emulsifying agent, then you cannot remove using gravity settling system. Gravity settling system will work better if you have larger bigger particle oil and you don't have any contaminant. Then after that you are passing to gravity OWS. Then maybe you are passing to centrifuge. Then you are polishing. Sometime you are using biosurfactant and many other things you are using. Okay, unit operation added to clean polish bilge water. Polishing steps like onboard oil water separation is more economical than holding onshore. Most post-gravity OWS separators are adsorption system, biological treatment, already have seen biological treatment, coagulation, flocculation, floatation, membrane technologies. Okay, so gravity OWS or centrifuge treatment, first step of bulk removal of non-aqueous component. Ultrafiltration, so the polishing stage, ultrafiltration also you can do, effective to remove turbidity and suspended solid, organic carbon, traces metal like aluminum, iron, and zinc. So absorption and adsorption. Absorption involves the integration of a substance from one physical state into another, such as liquid absorbed by solid. Adsorption refers to the physical adherence of bonding of molecules into the surface of another phase. In both processes, bilge water passes through sorption media in a reaction vessel or contactor. Oxygen removed, oil is removed from the media. Once the sorption media capacity is depleted, it must be replaced. Sorption media like granular substance, absorbent, cartridge filter, so many other there. Adsorption process is often used granular activated carbon or GAC. Sorption process suitable for smaller vessel less than 400 GT gross ton due to their compactness, relatively low capacity, operational cost, and ease of maintenance, especially when using modular cartridge. However, frequent media replacement may be required. Coagulation and flocculation. Coagulation and flocculation, often called emulsion breaking steps, aggregate small particle, making settling them easier. Okay, so small particle will be nearby together, they'll be joining and they'll make a bigger particle. After free oil separation in OWS, gravity based. Okay, gravity OWS, emulsified water is directed to a circular tank where flocculant chemical and air are added for flotation. So first you got OWS, gravity based system, then after that they are adding chemical and air and other thing. Okay, so step by step they'll be doing. So aggregation involves two steps: particle transport to interparticle contact and destabilizing attachment upon contact. The resulting floc and the oil are skimmed off and the remaining water undergo filtration. Drawback: sensitive to changes in effluent quality and required vessel specific optimization for chemical type and quantity. Air and gas flotation improve gravity separation by exploiting the difference density between the air gas bubbles and water. The difference causes oil droplet, small solid particle, to attach to the bubble and rise to the surface, whereas they are removed by skimming. So let's say I have one spot oily water mixture, and I have oil particle here. Now inject air or gas, so air will be attaching to these particles. So when air is getting attached, so those buoyancy will be higher. Attaching air increases buoyancy. Okay, increases buoyancy means it will be moving faster rate to the surface. So bubbles collides, attract to oil, increase right. So injecting bubble in a mixture. So what will happen? It will be bubble will be attached. Bubbles attach to oil particle. Okay, then increase rise rate. Increase rise rate. Gas bubbles to attach oil droplet and create higher aggregates that rises to the surface of water. So here I will draw one picture. Okay, so one is here, one is here, one is here, one. Okay, so I have eductor here, eductor here, eductor here. How the gas will be injected? So you create lots of bubbles here, bubbles here, bubbles here. Okay, and from where the bubble will be coming? Gas inlet here. Okay, not this one, like gas inlet. Okay, so gas is coming here. Just gas is coming here, gas, then gas balancing happening here, and gas is here, then it is going to eductor again, gas is going to eductor, gas is going to eductor. Okay, this is eductor. And recycled water, this is recycled water, and water from it is coming here, it is going here. I have pump, and pump is transferring water to there. Okay, and some water will be disposed here, clean water out. And oily water inlet is here, oily water inlet. So oily water is coming here, it is going through this, it will pass through like this, it will go like this, it will go like this, and you are creating wear hair skim out. Okay, so it is your here. Skim out. So this is skimmer, so you are taking oil out here actually, oil or skim out. So this is oil, this layer is oil layer, this is water, this is water, this is wear, Okay, and pump clear water out, recycle. So gas flotation unit, this is gas flotation unit. This is adjustable valve, this is adjustable valve, adjusting valve. Adjustable valve, this is gas bubbles, this is flow control valve. The flow control valve is like this. Control valve. Okay. So whenever you are drawing any valve flow control, then you should draw like this cross, then like this. Adjustable valve, only just this one. Okay. Flow control means one valve knob will be there, so using that one you can control. So that symbol, you should use proper symbols every time. And here one eductor I have written. Okay, eductor. So eductor actually it will create vacuum. Eductor or ejector or jet pump. So what happens, I already explained, I think jet pump will have like a small nozzle and it will be sucking some other fluid. So this way the eductor or ejector or jet pump will be working. So when sucking some fluid, that means you are creating a low pressure. For this one actually you just you see your desalination lecture. So there I have explained how jet pump will be creating vacuum for your multi filter system, MSF system. Okay.